So this example is to do with exponential models and regression. So the table shows some data collected on the temperature of a colony of bacteria and its growth rate. So we've got temperature and growth rate within the table. The data are coded using the change of variable x equals t and y equals log g. So it means that we've replaced t with x and we've replaced g with something to do with y. The regression line of y on x is found to be y equals minus 0.2215 plus 0.0792x. We've got a couple of questions to answer on this. Part of it is to do with finding the actual model that connects the temperature and the growth rate. The first bit though is to do with this. So Mika says that the constant minus 0.2215 in the regression line means that the colony is shrinking and the temperature is 0 degrees C. Explain why Mika is wrong. So the first thing we actually want to think about is why Mika might think this. So if we're saying x is t and we're saying the temperature is 0, well, we're saying the t is 0 and we're also saying x is 0. So what we're really saying is that when x is 0, so when t equals x equals 0, I suppose, y is equal to minus 0.2215. So that sounds like the growth rate is negative, because remember we're talking about the growth rate, not the amount of bacteria. However, just because y is less than 0 doesn't mean g is less than 0, g being the growth rate. So the coding was that log g is equal to y. So we're really saying that log g is equal to minus 0.2215. So if we want to find the value of g from there, remember when you see log, we mean like log base 10. That's really what it means when it's on its own like that. So g is going to be 10 to the power of minus 0.2215. We're saying we obviously need a calculator to work out, which then comes to g being about 0.600 to 3 significant figures. And so quite clearly that is not a negative number, so that's why Mika is wrong. Okay, so the next part of the question we've got is that given that the data can be modelled by an equation of the form g equals k b to the power t, where k and b are constants, find the value of k and b. So the idea of this is that it's going to link to what we had earlier, which I'll just bring down so you can see, highlight it to you here. So it's this bit. So we had an equation for y and x. What we want to do is take logs of the relationship that we were given and then use that to actually find the values of k and b. Okay, so the relationship is g equals k b to the power t. So we can take logs of both sides and have log of g equals log of k b to the power t, and then I'm going to use the log laws to rearrange this. So that's going to become log of k plus log of b to the power t, and then I can also use the log law to bring the power to the front, so it's going to become log k plus t log b. So log g is equal to log k plus t log b. And the coding we had was replacing log g with y and replacing the t with x. Okay, so like so. And in the question we're given, we're told that y is equal to minus 0.2215 plus 0.0792x. So we're kind of just matching things up. So within that, we can see that log k is equal to minus 0.2215, and so therefore k is 10 to the power of minus 0.2215, which is actually what we worked out a moment ago. That came to 0.600, so we've got k. And to get what b is, well, if you look at the other part of this, so the x terms here, here, so that means log b is the 0.0792. So therefore B is 10 to the power of 0.0792. So that comes to 1.19. And so there we have it. We've got the values of K and B.